So what I'm going to do today is give an overview on how GD&T and what is GD&T, introduction to it, how and what is the significance in the industry and everything related to that. So let's pitch in. So what is GD&T? GD&T exactly is like a set of symbols which we use to describe the tolerances for a product or a design for any kind of sheet metal or casting, anything. So why do we want to learn GD&T and what is the significance of it? So GD&T, when you learn GD&T, it will enhance your design language. And say you might have seen all kinds of part drawings, maybe if it's a sheet metal casting or a machined drawing or even a plastic drawing, anything, if it is going to the shop floor, it would be having a GD&T symbol, and it would be having this feature control frames, maximum material conditions, and all this set of modifiers and symbols and all. So how exactly do you know that this whole should be machined in such a way, or how the tolerance should be encapsulated and everything is done? So from the design flow to the manufacturing flow and to the QC process, everything is conveyed through GD&T. These symbols give you the meaning for a part, how it should be manufactured, what is the tolerance it should be going through, and what is the size tolerance should be maintained, what is the geometric tolerance should be maintained, and everything related to that is given by GD&T, the set of symbols and the modifiers and everything. So as you know, manufacturing is a ever evolving field, and it is for any item which you see, which you use every day, it goes through a manufacturing process. Say in that field, and anything which is getting manufactured would of course use a GD&T symbol or anything related to that. So what exactly we want to get into this course is like, say first the GD&T, the symbols, how you can interpret the symbol, and how exactly you can signify like how it is going to get clamped to a vice, and how it is going to get quality control and everything. And of course you'll be knowing the tolerance stack part of it. So if it is a one single part, and if you got a certain tolerances and the feature control frames, you would be knowing how the part is going to get clamped and machined, and how it is going to get, say, QC. But then you need to know if it is a big assembly, say it's like an engine or a transmission. So how exactly would you know, like, if it all the all the parts when they are getting assembled, it doesn't exceed the size, total size of the assembly itself. So that time we need to know about the basics of tolerance checkups also. So that is also one part of it. And of course, in a very competitive industry as in India, you'd be wanting to know what is GD&T, and of course you would want to be say in a confused state, like you just give the tolerance and it doesn't work out for a machine, or it doesn't work out in a QC part of it. Say we might give a tolerance which it can't be achieved at all, or sometimes we might be interpreting the symbols wrongly. So these are the shortcomings which every designer would face. And of course, in our engineering courses, we don't get teached about GD&T itself. So in a curriculum, GD&T is not there. But then when you go into a design floor or a shop floor or whatever it is, of course we'll be having GD&T. It's like a essential part of it is becoming like essential part of the design phase itself. So of, if we know this GD&T, of course it will help in our career path itself. And you might be knowing how a part would get manufactured, and how it is getting machined and everything at all. So why is it important to follow GD&T, and why exactly everyone follows this GD&T? That is this other, without GD&T, if you use the common coordinate tolerancing systems and all, without any GD&T symbols, you will be following like a square tolerance zone. And a square tolerance zone, what exactly happens is like you'll not be following any position tolerance or anything at all. And then you'd be, there is a chance that good parts will get rejected. So that is the main reason why GD&T comes into the play. And there is a good chance that even the negative parts will get accepted in a coordinate tolerancing system. So that is one of the key features why we use GD&T, and that is why it was incorporated very long back. And if you go through all kinds of industries which evolved and industries over a period of time, everyone pitched into, and like 40 years, 50 years back, everyone went into this GD&T. They did not want to lose a lot of money by, say, lot of money by accepting bad parts or rejecting good parts. So it involves a lot of money, and of course, it also involves your brand value, and it also involves in the field like say warranty issues and everything else. And of course, this, if we follow a set of symbols, it is like just a process flow. And say from step one to step two to step three, if you know these process, if you know the how the process works, then you can communicate from, say, from the prototyping to the design phase to the manufacturing and to the assembly. For everywhere you can communicate in a single medium. So that is the one of the main valuable reasons why we go for GD&T. And its importance over a period of time has evolved. And and of course, many people want to learn GD&T. And if you, if you are a fresher or if you are going into say in the field of design, of course you would be knowing what is, why we use GD&T and what is the significance of it. But you might not know how exactly it is getting used or how you should interpret it. And there are many nuances to it, and we'll be going through that in the main course itself. And that is the main key part of the course itself. Where exactly we use GD&T. And so if you see in our day-to-day lives, you'll be using plastic parts, sheet metals, the tooling side of it. Say you might be using a car, the all the parts which are related to, except for the rubber parts or hoses and everything, they use GD&T. And how are they getting manufactured? Using toolings. So if you are going to the tooling side of it or to the manufacturing side of it, of course you should be knowing GD&T. And how significant it is, we'd be going even in microns or that level to go exactly to know exactly what is how it is significant and how exactly it is important. And a recent addition, say, in the field is semiconductor industries. You know about these chips and everything which we use in the cell phones, which we use in our laptops, tablets and everything. So that is a recent addition to it. And when you go for a chip industry, the tolerance is very very minute, and you would be speaking in microns. And of course, over there also we use GD&T, and the precision which is required over there is very high. And its significance is also becoming more bigger in this age of technology, and that is getting very much important. And of course, when you go for say you might be seeing your laptops or your mobiles and everything. In that phase, say whatever your part you see, either it might be made, would have come through say a GD&T symbol, or say the tooling involved would be having a GD&T symbol. So that much is the significance which we do not realize about this thing. This plays a bigger role in the manufacturing industries, the quality controls, and all the warranty issues. How significant is it is? We'll just go through those things also in this courses. And of course in this webinar also I'll just give a quick case study like how significant it is in one of my experience also. Of course in most of the cases in sheet metal you might ask me like how exactly it is in plastic, say it is like flexible part, how it is, how it is feasible and everything. In plastics also we use it, but the tolerance which we give it in a plastic and a sheet metal are different, or in a manufacturable part it is different. You may say if you see the in the aerospace industries or the turbines or the engines in the aerospace industries, they have a very high volatility of the tolerances which they involve. Since they are rotary parts, the weight significance of a rotary part is very much important in an aero engine significantly. So if if in that case how significant it is, like say when a part is measured in a CMM machine and everything, they go for they go for many iterations so that the weight is equally distributed over over the profile of the surface, over the circular surface. And of course in those cases also this these symbols help you attain those tolerances and help you attain, say, the quality which is required. And if you go for fighter jets and your regular commercial airplanes and all, say if there's one mistake and it causes a huge backdrop, and of course it's say financially to the company or to the, say, in the defense perspective, it gives a very high impact. So that is one of the reasons and one of the bigger significances in this field. I'll just move on to the next slide. And the next one would be like the medical devices which we see. Of course now the medical devices, if you speak of the word medical itself, you know how much significant it is. There are, say, many companies now which are giving say licenses to make the ventilators. Is there anybody speaking, Roshan?
Uh, no, sir. I'm just
Okay,
searching for
yeah, I
the
just heard a voice. That's why. Okay. So,
search.
there are a lot of companies which are making medical devices, and of course, the significance in making medical devices also is very high, and the tolerances involving those parts, since it involves the human lives and the cost of human lives also, the tolerances involved and the precision involved is very high. And of course there's a catch to this, and because of this health and risk safety thing, and that is one thing which we need to give a higher importance to this. And so next time when you see a part, or say when you see a drawing, if you can lay a chance to it, you must be seeing like a lot of symbols revolving around in each and every hole or each and every face to it. So how significant is it, and how significant it is to attaining the quality of the product, and that is very important. And if you are in this field of industry, you will be knowing like how significant it is, and say you might want to learn on how it is getting evolved. So this is one of the case studies which I want to give a chance upon. Say when I was working for a powertrain component, and say we used to perform these tolerance checkups for the powertrain components, and to check whether there's a clash or a gap. Whether there's a clash, then it cannot pass. So if you go for an automatic transmission or even the normal manual transmissions, if in an automatic transmission you'll be having like around many revolving parts, and of course the revolving parts move, and there's a chance that it might create a clash or it might create more connections over there. So for each of these parts involved, you'll be having these tolerances, and you'll be having the surface tolerances, the position tolerances, and everything. There was a case like one of the suppliers, we wanted to add another supplier to the manufacturing part of it. So in this case, the new supplier was very much new to the capabilities which are required for making it a transmission. And since we wanted to pitch in for a new geographical location, we could not compromise, and that he was the best supplier which was available, and we went ahead. And when we gave the drawing to them, and the supplier came back and said that, like, say, we cannot manufacture in these tolerances, and they don't have the capability to make a part in those tolerances. So we went back and we went to the customer and checked with them, like, what exactly, how much tolerance you can achieve. And once they did, we had to work out on all these tolerance stack-ups. And what exactly happened is, like, it took like 2 or 3 months to work out on all the stack-ups involved for a transmission. And in some cases there were a lot of clashes. So either we had to reduce the thickness of the part, or we change the tolerances involved, and we had to play a lot around so that we could achieve the quality. Of course, say if we are reducing one of in a movable condition, if we are reducing zero point 0.1 mm of it in one surface, and if it creates more gap also, it would be a problem. If it is creating a clash, then again it would give a much more problem. Say there might be situations where there is rise to warranty issues, there's a failure, and there are a lot of failures involving automatic transmission. If you go through the net, you will be finding a lot of failures involving the automatic transmission itself. So since it involves a lot of moving parts, it is a very critical, say, an assembly. I'm just giving an overview, like how exactly it works in a car. Now, imagine how it exactly works in an airplane engine. So that much significance it is to each of the moving parts involved. And so this is one of the case studies which I came across, and which we had a very big, say, complex situations arise out of, say changing one tolerance or one symbol and everything. There are much more different cases also involved. Say in an assembly, or in a, there might be like, for a small assembly,
So that is the significance which we are speaking of, and how and each of the tolerances and say each of the symbols involved gives a large significance to the assembly, and how exactly it affects, say, on a larger perspective for the company revenue and the company's goals also. So maybe you can just move on more to the next slide. And so this is the, say, the current trends involved in the automotive industry or the manufacturing industry concerning GD&T itself. So more and more companies are emphasizing on more quality parts to be made, and of course they don't want to lose money by making not so good quality parts. And of, if you have sufficient exposure to GD&T itself, nowadays it is a big advantage. But a lot of companies nowadays are asking for certified ASME engineers. There's a certification thing involved. I'll just come to that in the later part of the presentation. And say, if you are interested in, if you complete your GD&T certifications, then you've got a higher chance of playing a job, getting a job, and understanding more about GD&T also. There's a lot more emphasis on that, and that involves a lot of effort, and of course a lot of understanding of how GD&T works also. Yeah, and just go on. And yeah, so in addition, say it's an ever-evolving field, and the ASM is the governing authority, at least in America, for GD&T, and we got the ISO standard also. But then the ASM and ISO, there's not much say difference between them. Just the governing bodies change, and the symbols involving and everything follow the same, at least in this perspective. So the ASME governing body emphasizes and approves or gives a lot of feedback. They receive a lot of feedback for these symbols and everything. They go for revisions, say once in 10 years, at least that's been the norm for the past two revisions, and so on. So there's a lot of for the previous revision, it was having 14 symbols. The latest revision in 2018-19, there's only 12 symbols. So they removed two symbols, and there's much introspective to it. And still, many companies haven't moved to the new version of it, 2019. They still are using the old version. So you might be seeing those two symbols even in parts now also, and why they removed it and everything. There's a lot of emphasis also on that also. And say they add these modifiers, they add these new terms and everything, and how significant it is, and how do these terms affect your, say, your cost of your part, or how significant it is. It has a lot of emphasis pertaining to that. And of course, you might have seen uh, these zero ppm, zero defects, and these boards in a lot of industrial areas. If you go drive just to the lane in industrial area, you'll be having a big board outside your industry like zero ppm. So it's like they don't say, for if they manufacture 1 million parts, they want to achieve zero ppm. That is like they don't want to make even one part as a not so good quality, and that is the emphasis on quality nowadays. And that is how significant GD&T is, how significant quality control and everything involved around it. So if you lay your eye on this board, then you must remember like how exactly or how stringent the quality control norms nowadays are, and how or how high the aim is for each of the companies and to manufacture a good part. And of course, all the companies, say, I would say like all the companies nowadays are using GNT, and they lay a high emphasis and high importance to it. Say, of course, as I said, in aerospace, in medical, in automobile, and all the industries, there is GNT. And if you say a company is delivering a lot of successful products or high quality products over a period of time, and they follow these processes and they follow these manufacturing things and GD&T very high precision, with a very high precision. Uh, in terms of say GD&T, if you are stringent and say their their line of quality control is very good, and say their line of high quality products are very successful. Of course, uh, if if you deliver a lot of high quality products, then of course the consumer would choose your product. And that's the evolution, or that's the way the market derives. Sometimes you don't need a brand value. You just enter a country, you just put a very good product, the high quality, and then it's boom, it sells like hotcakes. And of course, many companies have attained their brand value just for their quality itself. And there are uh, say they achieve a lot of brand value with it, and of course they cater to the demands of the public. And if your quality is, it's like just saying, like if you are giving a high quality product, your brand value is picked up, and of course you will be earning, reaping the benefits, and you'll be earning a lot of money. So that is how the significance of say a high quality. Of course, this is not just for OEMs, even for smaller industries and smaller, small scale industries or medium scale industries, if you need to go for a tier 2 supplier, just goes for a tier 1 supplier also. You need to have this quality, and that's how tier 1 supplier or OEM accepts your part. So if you need to achieve those things also, there is this impetus on the quality of it, and you should know how exactly it is getting manufactured. Without knowing uh, the drawing level knowledge, or say how it works or how it is getting clamped or how it is getting manufactured, then uh, we might not know the basis of it. Yeah, that's what I was saying. It's like so. And I just want to emphasize in this phrase also, like the second part, say they emphasize on the very checks like for GD, not only GD&T, and also the tolerance stack-ups involved, and so that their part meets the design and quality standards. And this of course comes to from the tier 1 industries also, and for the tier 2 industries also. If you are from tier 1 industry, or say if you are from supply industry, if you are supplying part to the OEMs or anything, if it doesn't meet the quality standards of the OEM, then of course it gets rejected. So these are the small steps, or the last steps, which would involve in a decision making for a higher organization and everything. So these are the topics which we would be significantly covering in the course. Like, say, what are the important topics, or say what I would say, we can't leave one topic away from GD&T. If you know all the topics involved alone, can we say that, say we have covered GD&T? If you say I would leave one topic and just teach GD&T, or we'll just cover GD&T, then it doesn't work. At some point of time, you might be coming across a symbol, or you might be coming across one phrase which you might not know. So these are the topics or which we'll be going through. And of course I've covered all at least on the point spaces over here. So why we use the GD&T, and what is the significance of it, and just like I just gave a recap, or I say a brief impetus on how it works and everything, uh, the start of the session. And of course, what is the 3-to-1 principle, how significant it is to GD&T, and how significant it is to, say, measuring a part or clamping a part, and the datums, how what are the datums which we can give, and what is the significance between the 3-to-1 principle and the datums, and the rules and concepts of GD&T. Say we'll be having rule 1, rule 2, but what exactly is rule 1, what exactly is rule 2, what what does it imply, and what is the how it plays a role in each of the symbols. So that is also important. And say how each of the symbol is measured, and what is the significance of each symbol. That is the main key part of it. Of course, I will be going through all the 14 symbols. Of course, as you know, as I just told, 2 of the symbols have been removed, but we'll just go through all the 14 symbols, and how significant it is, and what is the tolerance zone, like how it is getting measured and everything, and the datums and the feature control frame. Feature control frames is the main key part of how a GD&T is portrayed to the in a drawing, and what exactly is a primary datum, secondary datum, what is a geometric tolerance, what is a size tolerance, and how you should read it, and how you should interpret it. Of course, the main key part, the material condition, say the maximum material condition and the least material condition, and bonus tolerance. And you also got these various modifiers involving accompanying these 14 symbols, and how it is getting affects them, or how it is getting implied when to use them. And yeah, just move on. And yeah. So, and here we also have this limits and fits. I just wanted to give a brief thing about this limits and fits. We might have come across this H7G6 fit, like
Sorry to interrupt you, sir. Can you be a bit louder, sir? Because
sure. Yeah. Okay. Is that fine?
Yeah, sir. Now it's good.
Yeah.
Sir.
Okay. Thanks for telling me that.
Yeah.
So of course, I just want to lay a brief thing about this interference fit, the sliding fit. We might have come across these terms and how exactly it is getting measured, how significant it is to a part or a hole and a shaft and everything. And we'll also be laying hands on 2D stack up and the tolerancing system which we follow, and how GD&T and this tolerance stack ups are involved and how interlinked. And also we'll be having like what are the various standards and various standards which ASME has given, and what is the difference between them. There is a lot of emphasis on those things also, and of course how you can achieve your ASME certification. I'll just be giving a brief outlook about that in a couple of slides also. And of course we'll be having like what are the frequently asked interview questions. There are a lot of questions which you might you can lay your hands upon, and yeah, you can move on. So these are the topics which are important, and I just wanted to give a brief overview like what are the topics which will be covered. So what is the future scope for GD&T? So GD&T will boost your knowledge in this field, and it will give a heads up for you in not only in the industry but also in design field, and it can boost your growth curve in the industry also. So it is becoming an essential skill set in today's industrial scenario, and you can become a dimensional engineer in the near term if you have interest in GD&T and tolerance stackup. And also you got this 3D stackup tools, which are lot of these things are evolving, like this VSA and 3DCS, and there's a lot of tools just like CATIA and ProE which are coming up. So there's a significance to them also. If you use the Six Sigma and root sum square methods and Monte Carlo method, there's a lot of terms revolving this 3D stack up tools also. And there's a significance for 3D stack up also, since it might give you a real-time analysis mode, like how a part might differ, or how say if 1 million parts are manufactured, how exactly if we give this tolerance, which part might fail or which part might not be in position over a period of time. So these are the things which might come up in 3D stack up tools. And long term, you can yourself evolve as a subject matter expert or as a trainer. A lot of industries want, lot of manufacturing, the OEMs and everyone want, say, a person with a certified GD&T as a trainer, come as a worker. So they want you to be, say, as an engineer working, and of course you should be enriching as the skills of your teammates and your teammates and your team members all around the world, just to enrich their knowledge and just to give an idea like how exactly GD&T works. Yeah. So this is like how your future scope can be. Since GD&T is say essential part of your design or you say manufacturing everything, if you learn it, it doesn't go for if it doesn't mean that you just have to go to that field, then only it is getting used. If you learn GD&T, it will be useful if you are in the design or manufacturing and anything in the field. So that is how significant it is. It is becoming just like a piece of a cake in a bigger cake. So that is how significant it is. And coming to this certifications, so ASME conducts a separate examination to get this certification in this domain itself. So if you go to this ASME site, you'll be having various courses, like you'll be having the 1994 version, the 2009 version, and the 2018 version. And if you see, for each of these things, you'll be having two levels of certification: the technologist level certification and senior level certification. So ASME, what exactly they do is like you can apply for an ASME examination through the sites, and say for a technologist certification, they charge you like around $450, and say for a senior level, they go for around $550 or something. They don't teach you, but they you have to go on. They got the standard books. You have to go through those standards, and you have to you have to go for an online examination. So how exactly does this work is like uh, I went for the 1994 certification. So in the 1994 certification, you would be having say 5 sections of it, and 5 different sections, say for this, for the for the position tolerance and the circular. For the position tolerance alone, we'll be having separate sections, and for your datums alone, we'll be having a separate section. So like that, we'll be having 5 different sections, and each of the sections you should be attaining at least 50% of the score, and as a total you should achieve 80% of the year score. So that is how significant it is. So if it is less than 80, you can attempt another you go for another attempt. It works like that. So um, of course everything would be asked from your standard book, and yeah, the standard book itself is a bit bigger, and you should be having a lot of you should be knowing everything in the standard book, and that is how significant it is. In the later versions, like 2009, they split the sections into like 9 sections, but the rules remain the same. So you should be uh, for each of the sections, you should be knowing or answering at least 50% of them right, and same way as a whole, you should be going for at least 80% of it correct. So that's how it works. And so the technologies is like you can it just says like you can interpret it correctly, and the senior level says like you can you can apply it correctly. So that is the significance or the difference between the two, I would say. Like and the technologist certification, anyone without any experience can go for a technologist certification, but for senior level you should be having at least 5 years experience. So that is the impetus which they lay on for the senior level. And this is all online. Say if you can, if you apply for an examination today, I think you can take your examination within 90 days. So they gave a lot of prep time for it, and you can book a slot for yourself in university, and you can attend the exam. So and if you're getting certified, it's like it's a badge in your car, in your shirt, and to say that you know GD&T. And as I said, a lot of companies and a lot of industries want people who are certified in GD&T. So that is the impetus on it. And say we know we know how, if I could say like how significant it is. Like I say, if you just say that I know GD&T, many people will say like I know GD&T. But if you say you are GD&T certified, it's like you approved your metal for in that course. It's like that. So that's how significant a certification course is, and that's how significant, and that's how say many people would want to achieve that thing. If if you can go to the ASME site, you will be having a list of people who have achieved the current numbers of the GD&T certification also. And of course there's a catch to this. If you're getting certified, your certification remains for 3 years, and after that you need to renew your certification every year. So that is how significant it is. So it's like say for 3 years I used it, and every year you can renew your certification. You can have your name in the certification list in the ASME site itself. So you'll be giving a you'll be getting a say a big certificate delivered and with a gold emblem of ASME. Yeah, yeah, that's one. So how exactly you can get into this domain? So if you're on the design field, you're already in the, say I would say already in conversation with GD&T, and you'd be coming across all these symbols and everything. So if you if you want, the chances of getting into this field are more if you are certified in this GD&T. And there's, as I said, there's a lot of emphasis on that. And say it's a additional skill to a designer's role, and say everyday life of your as a designer. And of course, by enhancing your knowledge, you're just opening more windows of opportunity in this bigger competitive field, I should say. And it doesn't mean that, say, GD&T is just for automotive or aerospace field. It involves a lot of fields nowadays. So semiconductors, medical devices, and the tooling field, aerospace, avionics, and everything related to the medical devices also. So that is the emphasis on it. So this knowledge also will improve your involvement in the development of the product life cycle. So say if you are working in the first phase of your design, and after it goes to the supplier, say the supplier would say that we can't make this tolerance, then of course you need to make those changes in the drawing. And then there's a lot of going back and forth. So that is a product life cycle. And how, say, making a change in one of those tolerances, how exactly uh, does this change affects the part itself. And you'll be, if you're, say, working in an OEM or anything, you might be coming across warranty issues also because of say a small GD&T symbol. So that is how significant it is. And so th- this is a it is a niche field. And say if you want to, if you get into the domain, there's no coming back. And you can say over a period of time you can become an expert in this field.